Hi guys, so as we wrap up this unit on quadratic functions, I just wanted to do a summary of everything we've learned so far. So what I've done is I've given us the three different forms of quadratics up here in the top row of our table, and along the side row I've actually broken this up into three different important things. So I want us to think about this as sort of a 3x3 grid of the things we need to know about our three forms of a quadratic. If you'll notice, I have worked very hard to make sure that we have not used the quadratic formula, and I would like you to not use the quadratic formula for any of the questions in this unit, including the review sheet and the upcoming assessment. We will be learning the quadratic formula next unit, and that's when I'd like you to use it. So everything we've done thus far, we can do without using the quadratic formula. So we have the three different forms along the top row, and then there are three general categories that I want us to focus on. One is the vertex, the second is x-intercepts, and the last one is how we graph. So I need to know how to do all three of these things with all three of these forms. Okay, so let's take each one in turn. Let's do, actually I should say, we should write down what we know because we don't know all of these things yet. But I do know if I have vertex form and I want to know what the vertex is, it's really easy. I find the vertex by inspection, right? V is HK. So it's one of the benefits of vertex form. So for example, if I have f of x, notice I'm using function notation. If I have f of x here, and I want to know what the vertex is, I just simply read it off of the formula, no work equation, no work required. Okay, what about in factored form? So in factored form, what I need to do is I need to first find my x-intercepts. I know my xv is the average of my x-intercepts. And then to find my vertex, I need to evaluate my function at the point xv. So I know my vertex is xv, f of xv. Or if I want to write it as xv, yv, we know those two things mean the same thing. Okay, so how would I do this example? Well, I can see that my x-intercepts are 4, 0, and -8, 0. I know that xv is the average of these two. Okay, and then in order to find my vertex, okay, what I'm going to do is I'm going to evaluate f of xv, or in other words, f of -2 equals okay. All right, so we can see that our vertex very clearly is -18. So that was a bit of work, but we can still do it. Okay, -2. All right, how do we do that in standard form? Well, this is to be announced, so that will be next unit. We can go over that next unit. All right, x-intercepts. How do I find the x-intercepts in vertex form? Okay, so this actually is a bit of work if you recall. So what we need to do is we set f of x equal to 0, in other words, y equal to 0, and we solve for x. Okay, so this takes a little bit of work, as you recall from last time. Let's do it. All right, so using basically reverse BEDMAS, we figured out our two x-intercepts for this example. Okay, and I prefer it always, guys, if you write it in the form of coordinates. Great. So how do I find the x-intercepts of factored form? Well, this is where factored form is super beneficial. We're going to use the zero product property, right? So we set, actually, okay, so again, we're going to set f of x to 0, or y equals 0, and we're going to use afterwards the zero product property. So actually, with standard form, we know of a way to do this, but it's actually not the best way to do it. So we'll learn a different way next time. But if you needed to figure out the x-intercepts of this, you could technically put this in vertex form, okay, and then repeat everything we did here. But let's just save this for another day, and we're going to say we're going to figure out an easier way to do this next time using, as you can imagine, the quadratic formula. Okay, how do we graph? Okay, so using our vertex form, factored form, and standard form. Okay, so when you're given something in vertex form, it's really essential for me that you're using 5-point mapping. I want to see that you have taken the you have taken the 5 points of our function and you have actually mapped them to 5 new points using transformations of functions. So in the end, we know that, say for example, the point -2, 4 has been mapped to the point 0, 1. And let's say the vertex 0, 0 has been mapped to the point 2, 9, and we can do that for all the points actually on this function. We can see where they've been mapped. Okay, what about when it's in factored form? Well, when we have factored form, okay, we need basically 3 points. Okay, and those points are the 2 x-intercepts plus the vertex. Okay, so if we look up top, we know that our x-intercepts are 4, 0 and -8, 0. And we also found that the vertex is 2, -2, 18. So if I went to graph this, I would have to clearly just indicate those points. Something easy we could do here as well is we could actually figure out what the y-intercept is if I just evaluate my function at x equals 0. Okay, so that would be a nice addition to that. So again, we're going to talk more about standard form and graphing standard form in our next couple of lessons. But basically, guys, I just wanted to overview these three things with you. Yes, with standard form, you could always put it into vertex form, okay, and do the graphing. But we're going to talk about different ways to do this in our next unit. Okay, so as long as you are up to speed on this, and as you can imagine, at the end of next unit, we'll fill in that last column with the new stuff that we've learned.